Can we get a big hand for Ed Beshore?
Well, thanks a lot, Shipard. This is a lot of fun to be able to come out and do this tonight, particularly in a more relaxed setting. So while I've got PowerPoint and that sort of thing, I really intend these to be just sort of a something we can talk around. And what I'd like to do is discuss three aspects of asteroids. One is how we actually detect them. And I'm going to use an example from the movie Deep Impact. How many of you have seen Deep Impact? Okay, most people have seen that one. And then I'm going to take a step down and we're going to talk about Armageddon, which is how we might mitigate an asteroid if we find one that's on its way to hit the Earth. And then I'm going to talk about a science fiction show that maybe a lot of you haven't heard about yet, but I'm pretty excited about. It's called The Expanse. It's on the Sci-Fi Channel, and I think it's really good. And I'm going to just use that as a conversation around the idea of mining asteroids and what it might be like to live in the asteroid belt and work there. But before we do that, I think Shipard actually mentioned the launch, and I can't ever go anywhere without showing people pictures of the launch.
4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Fireworks look good. Starting pump speeds and check pressures are within family. Screen chamber pressures have.
So I could just watch that over and over. It also happened to be the 50th anniversary of Star Trek that day, and that's why it was to boldly go to Bennu and back. It was a perfect picture, a picture-perfect launch. We were right down the middle on everything. We took off 185 milliseconds late. So it was really, really quite nice. We've already made the transition to normal outbound cruise to Bennu. We are having routine communications now with the Deep Space Network. Everything seems fine. And this morning, yesterday morning, we downloaded the first images from the cameras. And everything seems to be working well with the cameras, and the other instruments all have met their aliveness tests. That's the first task as we go along, is just sort of make sure that everything works. And then we're going to actually start calibrations. And then in February, we're actually going to hunt for asteroids with OSIRIS-REx. And we're going to see if we can find an asteroid it's called a Trojan asteroid that lingers about 60 degrees either side of the Earth as it goes around the orbit. They're really hard to find, and we're going to try to see if we can find one with OSIRIS-REx. But let's move on and just talk briefly about asteroids. Asteroids have been known about since 1801, when this guy, Giuseppe Piazzi, discovered the largest of asteroids, Ceres. It's about 600 miles across. And he was a Catholic priest. Catholic priests were generally scholarly, and they spent a lot of time looking at the sky. And he found this moving object that was clearly fainter than a planet and moving along pretty briskly. And that began the study of asteroids. And they were pretty popular for a while, and people started looking for asteroids. But eventually, asteroids kind of fell out of favor. About 150 years later, they changed from being something interesting to what astronomers started calling the vermin of the solar system. Because they would take these long exposure photographs. They would put a camera at the back of a telescope, open the shutter, and carefully guide the telescope for sometimes hours at a time. And occasionally an asteroid would come across the image and ruin their nice picture, sort of like a cockroach scuttling across the floor. And so asteroids became something not all that interesting. However, reality intruded, and we started looking at asteroids as a possible source of danger to the Earth. And there have been many instances of our understanding of how asteroids have had an impact, figuratively and literally, on the Earth. We believe that the dinosaurs were probably made extinct by the impact of a 6-mile wide asteroid that hit in Mexico about 65 million years ago. But more recently, some pretty amazing things have happened. In Tunguska, which is an area in Siberia, in 1908, an asteroid or a cometary fragment exploded in the air and leveled 80 million trees. So that's a pretty big deal. And There's nothing else in 1908 that could have done that sort of thing. And then just in 2013, 3 short years ago, we were all waiting for an asteroid called DA14 to fly by really close to the Earth, and we were going to have a lot of news conferences about it, and we were even going to talk about OSIRIS-REx. And our news cycle got interrupted by an asteroid, a small meteor that came in over Chelyabinsk, Russia, and injured 1,000 people. Fortunately, nobody was killed, and it came in at a very slant angle. The shock wave blew down and broke a lot of glass, and that's how people got hurt, because they heard the sonic boom, or they saw the flash rather, and they ran to the windows. And about 20 or 30 seconds later, the sonic boom came in and broke glass. So, but nevertheless, it really reminded us that these things come along occasionally, and they can represent a danger. Now, before Chelyabinsk in 2013, we actually got a pretty good reminder of how this could happen with the movie Deep Impact. And so I've got just a short little clip. So that kind of got our attention, you know, and made us think that maybe these things could be a problem. And so movies did help us bring to our attention the fact that asteroids could represent a problem. So there's science fact there. But there's this too. And this is one of the astronomers, and he's sitting there eating pizza, just like we are tonight. Floppy disks. Does anybody remember those? So, when astronomers discover asteroids, they don't hop in their Jeep and go flying down the hill. That's not the way it works. I've had the good fortune to work for the Catalina Sky Survey here at the University of Arizona, one of the most productive surveys that have whose job it is to find these objects, and we never did that. So we'll talk a little bit about how they're discovered. In fact, most of the surveys that have discovered probably close to 700,000, 800,000 asteroids now, right, Eric? Something like that. At this point, have been found because sponsored by NASA to go out to universities and other institutions and say, please use your telescopes for the purpose of looking for asteroids. And the UA is a leader in this area in the discovery and the study of near-Earth asteroids. And on the left, you see one of the telescopes for the Spacewatch survey, and on the right is the 60-inch telescope at the Catalina Sky Survey on Mount Lemmon. And so the way that those things are discovered is actually pretty straightforward and seems pretty reasonable. You take 4 or 5 images over the course of an hour or two, and then you register those images together so that the stars all line up, and then you blink them. And sure enough, if there's something there, you see it moving across the screen. And that's what's done every night at surveys like Catalina and some others around the world. And we have automated mechanisms for finding these moving objects, but ultimately at Catalina, their success can be really attributed to the fact that people look at every one of these images that the computer says, I think I see a moving object, and it's people who make the decision, is that real or is it noise? And and it's just pretty hard to program a computer to do what people, that eye-brain combination, can do so well. And so that's how objects are found. And the key here is that it's not really possible to find the orbit of an object. And what we're really looking for when we discover a near-Earth object is we'd like to discover, or we'd like to determine its orbit, because its orbit is a mathematical relationship that describes its future position. And the future position we're really interested in is, will it hit us? And it takes time to do that sort of thing. You can't do that in the course of just an hour's worth of observing. You need days, sometimes months of observations. And for near-Earth objects, oftentimes you have to continue to monitor them in order to really monitor their orbits and make sure that we understand how these things move among the planets. So if we were to fact check deep impact, I'd say first of all, and I didn't point this out in the movie, it starts out with like a 12-year-old or a 14-year-old finding this object in a telescope in his backyard. And because the surveys have been so efficient, kids are unlikely to find new asteroids and comets. That wasn't always true. Actually, amateurs were big discoverers of comets in the past. But today, the modern surveys are discovering objects that are 1,000,000 times fainter than you can see with your naked eye. So it's pretty impossible for amateurs to have a lot of impact in this area today. As I mentioned before, astronomers just don't drive down the mountain in a frenzy when they find something, and that's because in the short amount of time that you can observe an object in one night, you can't get an orbit. All you can really do is find it, determine where it may be in a few hours, observe it again, and then hopefully you'll be able to figure out where it is tomorrow night. And then if you see it again tomorrow night, and then maybe a week later, then you can really start to get an orbit on these things. And you can start to say, does this represent a threat to the Earth, or is this just a passive, interesting object, but not something we don't have to worry about? Certain types of comets, however, are indeed very dangerous. And the movie Deep Impact, it was a comet that actually hit the Earth. And comets are a little bit different because there's different families of comets. Some comets orbit between the Sun and Jupiter, so they go out several times the distance of the Earth from the Sun. But there's also what they call long period comets, and these comets come out from the very outer reaches of the solar system. And they approach the Earth. We've never seen them before because they have very long orbits, sometimes thousands of years. So we might not have ever seen these things with modern instrumentation. They come in very fast, sometimes 60, 70 kilometers per second. So if we happen to see a comet on an impacting course, a long period comet, that's on its way to the Earth, that's really bad news because they move really fast and we're seeing it on the impact trajectory. We're not able to say, well, this is going to be a problem in 100 years. It's probably going to be a problem in a year or two. And that's not a lot of time to really react. And the secret to discovering hazardous asteroids is find them as early as you can so we have time to do something. We have time to send a spacecraft to one of them and study them to figure out exactly what they're made of, and then we can figure out a process or a way to mitigate them. The impact scene I thought was cool, but the comet probably wasn't moving fast enough. If it really was a long period comet, it would make the distance between here and the International Space Station in about 4 or 5 seconds. So in that scene it took a lot of time, but of course they wanted a long dramatic sequence of comet explosions. But for the most part it would just happen and people would go, what's going on? They also used ballistic missiles to knock the comet out, so defense missiles. But they could not intercept an object in any time to do any good. We would have to find something much, much earlier in order to really deflect it. But they did use a bomb, and that's the common theme in both the Deep Impact movie as well as in the movie Armageddon. And a nuclear device probably would work. There's a lot of reasonably good science that says there's a way to do this, but not the way it gets used in either Deep Impact or Armageddon. So that's really kind of my thinking about Deep Impact. It wasn't a bad movie, but it wasn't a great movie. So Armageddon. So we're going from a okay movie to a bad movie, I think.
The United States government just asked us to save the world. Anybody want to say no?
I mean, who could turn down Bruce Willis? But he takes a ragtag group of, I think, 12 or 14 oil drillers, and they go up to, they take 2 space shuttle-like spacecraft, and they drill holes in this comet that's 600 miles across. Actually, it's an asteroid, and it's 600 miles across. And they're going to drill an 800-foot hole, and they're going to stuff a nuclear bomb in it, and they're going to blow it up. They spend a lot of time developing characters in this movie, but none of the characters are all that compelling. But nevertheless, they take a stab at it. It was a famous movie. This was their idea of what an asteroid might look like if he were on the surface, which is definitely not what asteroids and comets look like. And we can say that with some authority now because we've actually been to asteroids and comets, and we know what they look like. At the top two images here are some asteroids that we've flown by. In fact, one of them even has a little moon that orbits around it here. And then just last year, the Europeans sent a spacecraft to a comet called 67P Churyumov-Gerasimenko. They orbited it and flew with it for over a year and watched this comet activate as it got closer and closer to the sun, as it began to outgas. And they produced some absolutely fantastic imagery of this comet as it began to activate as it flew closer and closer to the sun. They tried to actually land a probe on it called Philae, in which they were successful in landing it. Unfortunately, Philae hit a little bit hard, and when it hit the comet, it bounced 2 kilometers, and they lost it. But they found it just a few weeks ago. But unfortunately, the end of the mission's coming up right now, so it was a little late. But the key is that asteroids look something like the moon in some cases. They have craters on them. They clearly have been impacted by smaller objects. The larger ones have a layer of dust and dirt. We call it regolith on the surface, and in fact, that's what the OSIRIS-REx spacecraft depends on to be able to collect when we get to the asteroid Bennu. We're really looking for Bennu to have some loose material on the surface, because that's something we can collect relatively easily by just touching the asteroid for a few seconds. We don't have to try to land. We don't have to try to attach ourselves to the asteroid, because it's really hard to do that in a microgravity environment. These asteroids aren't very big. They don't have a whole lot of gravity. And so that's really what asteroids look like. We're going to use an atomic bomb to split the asteroid in half. And of course, everybody's very happy about that. But that's probably not how you would want to do it. Because we think also that a fair number of asteroids may actually be rubble piles, that they may not be solid objects. And this is an example of one called Itokawa that was visited by a Japanese spacecraft several years ago. And we think that there's at least 2 large single structures here that are kind of held together, and they're probably just touching and held together by loose gravity, and then kind of nicely coated with a covering of regolith and smaller objects, some pretty good sized boulders, as well as some dusty areas. And it's very likely that even these larger objects could be rubble piles themselves. So if you were to go up and try to blow one of these things up, you might just create a shotgun blast and not really do what you want to do, which is move the whole thing out of the way. So, and you certainly wouldn't want to push on it if it was a rubble pile, because if you pushed on it, it might just come apart, and you would have done very little or nothing to solve the problem of an impactor. So how would you deflect an asteroid? Well, probably, I've been to several conferences, and I know that there's changing thoughts about how this might best be done. I've talked to some folks who work at Los Alamos, and they think a nuclear device is the way to do it, but you wouldn't blow it up. You wouldn't drill a hole into the asteroid and try to blow it up. What you might want to do is actually explode a weapon in close proximity to the asteroid, because a lot of nuclear weapons produce a high flux of X-rays. And those X-rays would strike the surface and instantly boil the top several inches of the surface off of the asteroid, and that boiling rock would escape as vapor and actually act as a rocket thrust to push the asteroid aside. So what you would want to do is actually just explode a weapon or a nuclear device in proximity to one of these objects. And that could work probably equally well for a solid object or for a rubble pile. There's a lot of folks who believe that if you have time and the object's not too large, you could use something called a gravity tractor. And it's because these things are small objects, relatively. Some of them are only 300 meters across, something up to about 300 meters across. That's not terribly huge. The asteroid that we're going to with OSIRIS-REx is 500 meters across. But objects up to about 300 meters across, you could probably just sidle up to it with kind of a heavy spacecraft. Maybe go grab another rock and then just go station keep alongside it. And you literally could tug it away with just the mutual gravitational attraction between the asteroid and your spacecraft. And it would take time. You would have to have probably an automated system. It would be kind of a long station for a person to be out there, flying the spacecraft. It would probably take, decades in order to move these things sufficiently. But if you had the time, you literally could tug an asteroid out of the way with this so-called gravity tractor. Another thing that seems to be getting a lot of interest right now is something called a kinetic impactor. That's just a way of saying I'd hit it with something hard and fast. And if it was solid, that might work very well. And in fact, there's some plans right now to actually do an experiment. The Europeans are going to be flying a space mission to an asteroid in a few years, and NASA is considering having an allied mission called DART, where we would fly to an asteroid, fly around it, and then this asteroid actually has a little moon, like I showed you in the earlier picture, and we would actually try to move the moon of that asteroid, the little small 20, 30, 40, 50 meter object, with a kinetic impactor. We'd hit it hard and fast because we could use a rocket and we could hit it at several kilometers per second. We've actually done that. We actually had a mission not too long ago called Deep Impact that actually hit a comet. And the idea there was not to try to move it, but it was to act as a geologist's pick. I don't know if any of you know any geologists, but if you go hiking with them, they generally got a hammer and they're just hitting all the rocks as they go along. And because you can tell what's going on, and if it rings, they can say tell you what kind of rock that is. But they're also interested to see what comes off when you hit a rock, because you want to actually look at a fresh piece of it, and that's how you do it with a geologist does it. This is what Deep Impact was doing, was knocking material off so you could study the fresh material underneath it and see what the comet was made of. So we were able to actually hit a bullet with a mission several years ago. So that's actually a relatively low technology approach towards doing this. So a kinetic impactor. Something else you could possibly do would just be paint it white. Because sunlight actually imparts momentum to asteroids as well. So it can actually push things along. And so we could probably get the Seidlitz company to co-market and paint the asteroid with white paint. And if we had enough time, solar radiation pressure could literally change the orbit of the asteroid by just changing the color of it. The key here is that all of these techniques are dependent on how the asteroid is put together and how much time you have to do this. This kind of goes to a question you had asked earlier, sir, which an asteroid deflected 20 years before impact would need about a 1 inch per second change in velocity to miss the Earth by about 10,000 miles. So that's the key. Find them early. Find them early. That's what these asteroid surveys are all about. So fact-checking Armageddon. 600-mile wide objects are very unlikely to be a surprise today. The very first asteroid that we ever found was 600 miles across, and that was in 1801. Giuseppe Piazzi did that. So I would doubt very much that a 600-mile wide object would simply surprise us. Exploding a nuclear weapon internally would probably be a bad idea, and furthermore, nothing in our arsenal would affect such a large asteroid. A 600-mile wide asteroid, I found a paper actually that was called "Could Bruce Willis Save the World?" And they determined that in order to split a 600-mile wide asteroid, you would need 190,000 trillion tons of TNT. You compare that to the largest nuclear weapon that we've ever exploded, which was a Russian bomb that was 57 million tons. We're just way outclassed in terms of being able to do the job that Armageddon suggested that we could do. Asteroid surfaces don't look like Superman's Fortress of Solitude, and we know that. And overall, the movie was in general bad. So that was just my own facts. I should let you know, I actually watched that movie again for you people about 2 weeks ago, and you owe me. So I want to finally finish up by talking about a movie, or a television series that's on the Sci-Fi Channel called The Expanse. And I don't actually have any clips from it. I couldn't find anything in time, but it's effectively a whodunit. It's all about a guy who's a detective and somebody goes missing, but it all takes place in the asteroid belt. And the asteroid belt is being mined for water. and for materials. Mars has been completely colonized, and Mars and Earth don't get along so well. And the resources of the asteroid belt are highly coveted, and it looks like somebody's maybe playing some games. But the key is that the special effects are quite good. The acting seems to be pretty decent, and I haven't found any serious problems in watching the first season of the show. And the potential of asteroids as resources is pretty high. We have to do a lot of technology development before we really could get to the point where we can exploit the asteroid belt. But asteroids are divided into different types. We have C-type or carbonaceous type asteroids, and that's what OSIRIS-REx is going to. And we think that they have a fairly high abundance of water. We think it could be about 22%. And now that's not the kind of water where we would go find a lake on an asteroid, but it's chemically bound up in the rocks, and it could be released by the application of energy, perhaps a solar energy to boil the rocks and pull some of the water directly out of the rocks. When you see a volcano going off, a lot of what's coming out of a volcano is steam. And that is water that's being released as hot magma comes up from the earth and comes up into lower pressure, and that water boils off, and so that's what you see coming out of a volcano. So some of the other key ingredients that you would find in a carbonaceous asteroid could probably be useful for growing things, and that's a big problem. Eating when you get out to the asteroid belt is something you want to think about doing. So C-type asteroids look like they could be a good thing to mine. S-type asteroids are have a lot of silica. They're rocky asteroids. They don't carry a lot of water, but they do have metals, and there's nickel and cobalt and even more valuable platinum group metals in these kinds of asteroids. A small 10-meter S-type asteroid contains about 650,000 kilograms of metal, and probably 50 kilograms of it would be rare metals like platinum. A 1-kilometer asteroid, which is still a pretty small asteroid, would contain about 7,500 tons of platinum, to the point that it would probably destroy the platinum market. But platinum's a pretty useful thing to have. So, there's a lot of work to have to be done, but there's enough interest in this that there are actually companies now that are focused on trying to mine asteroids. They're trying to figure out how would we go about doing this. M-type asteroids are rare, but they contain up to 10 times more metal than S-types. So there are resources there, and it's not just for the metal, but water can actually be turned into rocket fuel. And so asteroids could represent filling stations for our exploration of the outer solar system. If we could go to an asteroid and pull water out of it, that water can be decomposed into hydrogen and oxygen, which is the same rocket fuel that the second stage of the OSIRIS-REx spacecraft used. So it can be a very potent rocket fuel. So there's a lot of resource potential out there, but there's a lot of technology that has to get done before we can make that. So briefly, I would say in fact checking the Expanse, I'd say first of all, sci-fi has a pretty good science of the Expanse section on their website. And so if you go to the sci-fi website, they talk a lot about the last season and the science of each one of the episodes. Now, one of the things I noticed is that they don't use what's called the Minor Planet Center designations for asteroids, and it's a small thing. It's for purists like me, but I thought, gosh, we actually have a perfectly good way of giving asteroids names, and they chose not to use those. I'm nitpicking around the edges, but that's all I could find. If we're to successfully exploit the asteroid belt, though, we're going to have to come up with some sort of automated exploration systems, and we think that you might actually use a lot of the technologies that spacecraft like OSIRIS-REx we'll be using to explore the asteroid Bennu. We've pioneered a lot of technologies with our mission already because we've come up with new novel ways to navigate around small bodies like asteroids and to survey them, to produce maps and come up with the compositions. But we also need other technologies that are better propulsion systems than we have right now. Solar electric propulsion looks very interesting, and we've used that to explore the asteroid belt already with the Dawn mission. That's really ion engines that use xenon gas, but they're extremely efficient. And using technologies like that, we could send a fleet of small automated bodies to go out and start surveying the asteroid belt. One of the other things that's cool about the Expanse is something called the Belter language, and it's kind of compelling. And there's even a fairly large dictionary now of the language that these people who live in the asteroid belt use. So for instance, they have a term called a pomang, which is based on Portuguese and English for man to refer to people who live on the dusty world Mars. And they've developed a fairly extensive dictionary of terms that they use in the show, and it makes it much more interesting. So with that, I actually did run more than I wanted to with slides, but that's what I do for a living, so I'm sorry. But if you have any questions, I'd be delighted to take them. Otherwise, I'd like to thank you very much for coming out. It's been a lot of fun to talk to you. And if there's anybody who has any questions about what you've heard, please raise your hand and Shepard will come over.